Hello wonderful person, this is Anton, and in this video we're going to be discussing a discovery of plutonium in a very strange location on the planet, at the very bottom of an ocean. And as you probably know, plutonium is actually a very important element in nuclear technology, so its discovery here was a little bit unusual. And while trace amounts of plutonium can be discovered in certain locations, today most plutonium is actually synthesized in nuclear reactors and essentially has artificial origin. And so the question here was, of course, where did this plutonium come from? And the answer seems to be outer space. And so what makes this particular discovery so important is the fact that this is from an ancient explosion and essentially serves as a kind of a tape recorder, telling us exactly where heavy elements in the universe come from, and more importantly, where and when some of the most extreme cosmic explosions happened close to the solar system. But first, in order to connect these dots, we have to discuss the element itself. And so here we have to discuss plutonium-244, the strange isotope discovered and reported in the study you can find in the description below. And well, here this isotope is exciting because it's not as radioactive and does have a pretty long half-life. So here it's a special isotope with a half-life of approximately 81 million years. In contrast, a lot of other isotopes are usually man-made and have a much shorter half-life. For example, the one that's used in a lot of space missions, such as the Voyager probes, is plutonium-238, and it has a half-life of approximately 87 years. Whereas plutonium-239, used in nuclear weapons, has a half-life of approximately 24,000 years. And so in this case, plutonium-244 is actually the most stable isotope in existence. But because it was discovered on the planet, it means that it has to have come here within the last billion years. So essentially it couldn't have been here from the beginning and has to have been created by something in a relatively recent geological history. And so if we do find it in the deep sea rocks, it can only mean one thing. It has to have come from outer space and very likely extremely recently. So basically here we're talking about some kind of an interstellar fallout from some kind of a relatively recent and relatively nearby explosion. But the thing is, most explosions known to us, such as various supernova, cannot actually produce this naturally. They're usually not powerful enough. Which means that this came from something even more extreme. And though scientists have long debated the origin of a lot of these heavy elements like gold, uranium, and plutonium, in 2017 we finally got a definitive answer. These elements seem to be created during the so-called R process, or rapid neutron capture process, during some of the most extreme events in the universe, the collision of neutron stars, which result in the production of a kilonova. You can actually learn about the 2017 event in one of the videos in the description. And well, as of today, this is the only event known to us that's able to produce all of these very heavy elements, and that technically have been detected when a distant kilonova was analyzed with modern telescopes. Which basically means that these collisions are almost like miniature Big Bangs. In that fraction of a second when the two neutron stars collide, they're able to generate an extremely hot soup of particles that then cools down and coalesces into a lot of heavy matter, basically creating these much heavier elements that normally do not exist anywhere else. But these events are also extraordinarily rare. For example, in a galaxy like the Milky Way, statistically there might be 10 or so star systems that are destined to become kilonova sometimes in the next billion years. And as of today, only one specific system has been identified that seems to have the right properties to one day create such an event. This is about 11,000 light years away from us, with this particular system evolving in approximately a million years, leaving behind two neutron stars in a tight orbit that will most likely collide millions of years afterwards. But going back to that study from the Nature Astronomy, the study by Dominic Cole and his team, in this case it's also the analysis that's really exciting. And specifically because they analyze something referred to as ferromanganese crust. The crust recovers from the Pacific Ocean. And here you can think of this as an extremely slow-growing rock that adds layers over millions and millions of years. And as it does so, it usually traps a lot of stuff that settles on the ocean floor, essentially creating a kind of a history book. And so by using a technique referred to as accelerator mass spectrometry, which is usually sensitive enough to count individual atoms, scientists wanted to find two specific things, iron-60 and plutonium-244. And that's because iron-60 is a known signature for various supernova, but plutonium-244 is not. And if plutonium does come from supernova, we should be seeing the levels of both going up and down together. But as predicted, they weren't. Here the team discovered distinct peaks of iron-60 from the previously detected events approximately 2.5 and 7 million years ago. This is something that has been known to us for quite some time because other studies discovered this as well. But none of these contain plutonium, and the plutonium influx seemed to be a lot more constant and independent of supernova, which is why they decided to focus on a second element referred to as curium-247. This is usually produced along the plutonium-244 isotopes in the same R process in these powerful explosions, but it decays much faster and only has a half-life of 16 million years. And so because they're usually produced together, the overall ratio of these two elements can actually tell us about when this event happened. And so if this kilonova happened relatively recently, we should be seeing both curium and plutonium in relatively high abundance. But the study found no significant curium-247, suggesting that almost all of it disappeared. And so by counting how long it would take for curium to transform into other elements, researchers determined that the last major event must have happened at least 95 million years ago. So essentially during the time of dinosaurs. And though this is obviously a very long time ago, this does have some implications for the local neighborhood. First, this suggests that there is a kind of a diffuse background involving a constant low level of plutonium that seems to be coming from outer space and landing on our planet. And this suggests that the solar system is traveling through a relatively large interstellar dust cloud that was left behind from this very old, very powerful event that was close enough to us to potentially affect the planet in some unknown ways. At the same time, this also confirms that these events are indeed super rare. In other words, it confirms how rare these gold-producing collisions are, since the last one happened 100 million years ago, while also confirming that this was not from supernova for sure, and regular supernova cannot produce these heavier elements, with pretty much all of the gold, plutonium, and uranium coming from several of these events that happened close to the solar system billions of years ago. But even though supernova do not produce them, there's a very high chance they might help distribute these elements by producing very powerful shockwaves, allowing some of these elements to travel across the galaxy. And so, in other words, that gold in your jewelry and all of that plutonium in the depth of the ocean possibly originated from one single event that happened somewhere close to the solar system around the time of dinosaurs. And though obviously a lot of other gold and platinum, especially the stuff we find inside asteroids, was most likely created by other kilonova, in this case a lot of the newer material most likely came from this event, which means that we're literally walking and swimming over ancient debris of a neutron star collision that happened approximately 95 million years ago, making this a somewhat sober reminder how Earth is connected to the rest of the galaxy through these violent cosmic events. But at least for now, that's I guess all we know about this event, and all we know about all of this plutonium in the depth of the ocean. Once we have some other discoveries, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can name it directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.